Hello everyone, thank you very much for joining me again. Today is a very important day because we are going to finish part 1, the fundamentals from Spring in the Spring Start Here book, which you probably know because you are already watching this series for 9 episodes or so. Is this book here, and look, here it is, if you want it on paper. And we are finishing chapter 6 with a very important subject today. Now we have started chapter 6 last time discussing the aspects and the AOP part, which, to give you a reminder, is that other implementation of inversion of control that it's related to the methods. It's actually, we can say, related to objects behavior, no? Because when we talked about the context in chapters 2, so let me actually share the screen to see. In chapters 2 through 5, we discussed the Spring context with a lot of important things, all of them related to how Spring manages the dependencies between the beans and how it manages objects that you tell it can manage by putting them in the Spring context. In chapter 6, we started with the second part, which is related to managing the behavior of these objects through aspects, which we call AOP, aspect-oriented programming now. And we have implemented the first aspect in the previous discussion. But we have only triggered the aspect on the execution of a specific method. So we have used an aspect_j expression to tell Spring that it needs to weave an aspect to a given method execution. And we have learned about what the point cut is, what join points are, which are all the components and the steps that we need to follow to describe an aspect and to enable it to make it work in your Spring application. And we have actually stopped with the discussion of how to use annotations to enable aspects on, or to weave aspects to different methods. Why is this a very important subject and why are we focusing very much on this today? Is because in reality, this is the most encountered approach to link aspects to the execution of given methods, and this is also the way in which Spring itself gives us the opportunity to use certain capabilities it implements to augment the execution of our application. That's why we see in many cases we learn annotations. So since many years already, since we've stopped using XML files, which were the initial configuration way for the applications, we have started using annotations. And that's why we will learn given annotations and how to use them. But what I'm going to tell you today, what you're going to learn today, is how these annotations actually work behind the scenes. You will learn that you can create your own annotations, which happens sometimes, and which sometimes you might need, creating your custom capability that you want to weave to your application through Spring, or using given capabilities from Spring through the means of annotations, like you do with the @transactional annotation, for example, or pre-authorize, post-authorize annotations from security, and so on and so forth. And yes, hello everyone, I'm live now, so you have a live chat there if you are here with me, and I see many of you already joined me. Don't hesitate to write in the chat, because I'm always taking a look on the chat and see your messages, and thank you very much for all your nice messages, but also your questions. with this being said, let's begin now the discussion about the specific topic for today. So how to use annotations and how aspects are linked to the annotations. How do this work in general? We might know, and if you don't, I remind you now that annotations are an element of the Java language which has been introduced somewhere around Java 5. It says also here in the first paragraph. And the annotation is you can think about it as an enhanced marker interface. You use it to mark given elements like a method, the parameter of a method, the field of a class, the class itself, the exception thrown. You can mark, I think, almost anything in Java using annotations. And then when you mark all these things with a purpose, you can then operate with the annotation. You can implement something, for example, if you have like a compiler or a code parser saying if there is an annotation here, do something specific. And that's, for example, an annotation that works at the source code level. Or you can even have your bytecode instrumenting over the annotations, and that's what's called a runtime annotation. And naturally, this at the Java level you can do through proxies, through aspect proxies, or by using cglib, which is a library that we have also discussed about in the previous episode, being that capability Spring uses when you don't use interfaces but classes, because it's a little bit of more difficult. The JDK itself doesn't allow proxies on the classes directly, so Spring has to work around that somehow. When you use classes instead of interfaces for proxies, it needs to manipulate in a different way those classes, and it uses this dependency called cglib, which you also might see if you have the logs enabled in the console. Now, if you wondered what that cglib is, that is what Spring uses to interfere with the execution of the methods for class references. So I'm doing good, and I hope that you are also doing well, because we have again, we have a lot of things to discuss today and to demonstrate. So it will require, I believe, if you are attentively watching me, some cognitive effort from your side, because you need to learn a lot of things. No. But again, before we are going into the code to also see a little bit of the code presented with the examples of this chapter, I want to go through the chapter itself and discuss also using these nice visuals, because normally the mind is helped a lot by seeing things. We are visual creatures, and it's easy for us to remember things if we see something. That's why it's easier for you to remember something from a movie rather than a paragraph from a book. And that's why my books have plenty of visuals to help you do that. So take a look here. This is how an annotation is declared. Okay, you use the normal interface keyword that you normally use when declaring any interface, no? But you have to put this @ symbol in front, so no spaces, no nothing. You say public @interface and then the name of the annotations that you want to create. And that's usually enough, but normally whenever we declare interfaces, we use at least these two annotations over the annotation. So we annotate the annotation declaration, which is funny. I always find this funny, but it's very important, no? So because we use an annotation to create an annotation. Now, okay, going back. So normally this is enough to declare the annotation. Why do we use these two annotations over? Because we normally want to minimize the places we allow the annotations to be used. So for example, if you want to create an annotation that can only be placed over methods, then you have to use this target annotation and specify exactly for what kind of element of source code elements can this annotation be used. If you don't put at all this annotation, then this can be used everywhere. And it's a bad practice to allow an annotation to be used somewhere where it's not usable. No, you prefer the compilation to fail if someone tries using your annotation in a place where it doesn't make sense. Using stones to destroy stones, probably something like that. I think I had the same on my mind. No, it looks a little bit hilarious. But that's the case. So that's first point. You declare the target such that your annotation cannot be used where it's not meant to. If your annotation is meant to be used on methods and only methods, then declare that, and that's it. And then very importantly, this first number one, retention, which you will see almost with all, probably with all the Spring annotations. You'll most likely see it with all the other frameworks annotations, with some exceptions. This retention is the one that tells the JVM that this annotation exists also at the runtime. If you use it with this policy called runtime, you have three policies that you can use: source code, class, and runtime. And runtime is the only policy that makes this annotation visible at the execution. If you do not use the runtime policy, the annotation will not be seen by reflection, by Java reflection, which means it cannot be used by your aspect. And more important than that, even more important, all the annotations are not runtime by default. So if you don't use that retention over the annotation, your aspect will not see the annotation. Do not forget to make your annotation visible at runtime if you want to use it with aspects. Okay? And then the second step is we use the join point, which can be around, before, after returning, after throwing. Now we've discussed about the 5 join points annotations last time, and then you have to use a slightly different expression, aspect-J expression, than the one we have used in the previous lesson to define the point cut. Now, if in the previous time we have used the execution word, and we've used like execution of, if I correctly remember, was any method in the services package. It was in the example, in the last lesson's example. Today we just say we don't care in this case where it's from. We just want any method of a bin that is annotated with the toLog annotation, which is the one we have just created, to be intercepted with the around join point. Okay? And now I rely also a bit that you have seen the first part of this chapter, no? Because normally we have discussed last time about how to declare this. Okay, so in case you've missed the previous episode, you can anytime go back and review it to understand better the first part of the chapter. So know that this one, no, this is what I was talking about. Very important to understand how the aspect works first. No, look, in the previous example we were using the execution here. That was what I was telling you, saying we want to weave the aspect over any execution of any method with any name, with any parameters in any subpackage of the services package. Okay, but again, good news, you don't have to remember by heart the aspect-J syntax. Anytime you can review it and use it whenever you need it. Today we also have the easy way of using ChatGPT or an AI tool to say, hey, give me the aspect J expression for a specific point cut, and it's pretty easy. So you don't have to memorize the aspect J language. It doesn't make sense, but you have to be aware what it is. Now, why do we use it? Where do we use it? Okay, and that's why do we use it. So now of course, this is actually the example where you can see in this code snippet the annotation that has been declared, and then a bean defined as a bean using a stereotype annotation service. And you see that out of 3 methods here, 3 fictive methods, which are simply just logging something. No, we just imagine this comment service has 3 use case methods, implementations: publish comment, delete comment, edit comment. They do nothing, they just log something for us to see if they are called or not, because that's what is relevant for us today. And you see that only one of them is annotated with the toLog annotation. So I'm going to go in my IntelliJ here, okay, and let's review this together. So we have this logging aspect in the aspects package. This is actually a more complex example. Is the last one. It's talking about the aspect chain as well, but don't mind it. It's not relevant. I will talk about this annotation a little bit later, so don't look at it for the moment. It's not relevant for you. I'm just talking about the things that you have already seen now and explain the annotation part, and then I will go back and we will also discuss about having an aspect chain, which is actually having multiple aspects. Now, when you have multiple aspects, which is possible, which is something that happens in real life. And we will even discuss a real world example where this happens, because it's very important. So again, take a look at this. I'm going to services, comment service. No, not this one. This one, okay. And you have, okay, you only have a method. Now let me actually open the right example, because then I will be, you will not understand properly what we are talking about. So normally I should have written here which example are we talking about, but I might also have, look here, it's example 4, yeah? So this is the name of the project we are interested in. So let me actually open that project. So it was the 4th now, no? I'm gonna open this one precisely to make the life easier for all of you. No, and let me actually talk on the right example to make things easier. With this book, now you have seen that we have a lot of code examples. So recommended is you always use the examples, not only read the book, but always try to use the examples to understand properly what happens. No, so to also see them applied, and not only take the theory out of the book. The book is also its fundamentals, but it's also made in a practical way with code on your hand to help you understand better. So look, we have the toLog annotation. You can see it, right? So very importantly, we made it retention runtime. And again, you could have had it in 3 different retention policies. It's either runtime, it's class, or it's source. And we made it runtime because we want to be possible to intercept this annotation during execution. Remember, if you don't do that, the annotation will not be seen. And then you just use the element type to say, I want this method to be used only on methods, because if you don't have this, look, I commented it out. No, if I don't have that, then you would be able to use this toLog annotation literally everywhere. You could use it for parameters, you could use it for the class itself, you could use this for absolutely anything else, attributes of the class, so on and so forth. But it doesn't make sense because the logic we will create for this annotation is not meant for annotating classes, parameters, or anything else than methods. The only purpose of this annotation is to annotate a method to which we want to weave an aspect. So that's why we use this target annotation here, so that we make sure that any improper usages of the annotation will fail the compilation. See now what happens. So when I uncommented the line, which means that I only allow the usage over the methods, then it's not compiling anymore for the class and for the parameter. No, it's only compiling on the method because that's only the only place the target allows to. And this, yes, you might have multiple targets. So this is actually an array here. So you can do something like this. You can say, I want this to be applicable on methods and on types. No, and whatever, you can have as many as you need. No, so that in this case, you will have other places where you can put it. No, annotation type. Sorry, I wanted to use the type, not the annotation type. No. So you can see here now, this one compiles, this one compiles, and only the parameter doesn't compile. See, this is a method. Okay, this is a method to have the annotation usable on classes and methods, but not on anything else. Good, which happens, for example, for the transactional. No, the transactional annotation, which if you haven't used it, no worries, in part 2 we will see it. You will be able to use the transactional annotation at the class level and at the method level as well, and that's how it works. That's why you are able, because that transactional annotation is defined as a target for both types and methods. So I will take it out now from where I shouldn't use it. Okay, and I will only let it here. No, so now let's see, we declare this aspect, which is an around, and which says, no, apply this method to any execution of a method annotated with this annotation. Very simple. So automatically now, whenever any method annotated with this annotation is called, which in my case will be the delete comment, the aspect will wrap around the method execution. No, and we'll wrap around it because we have used the around join point. Remember, we could have used the before, after returning, after throwing. So now let's see if what am I calling? I'm calling all three methods on the comment. And then the question is, which will be actually triggering the aspect? And the answer is only the delete comment will trigger the aspect, because edit comment and publish comment are neither of them annotated with the toLog annotation. So if I'm running this now, I should be able to see that the aspect is only triggered once, because only this method, the delete comment method, will actually trigger the comment. Wait a couple of minutes max, and let's see it. Okay, so we see here publishing comment demo content, okay, which is the log coming from the publish comment, which proves that the publish comment method has been called. Then it's followed by the message from the logging aspect, and that's because the next method is the delete method, which is not directly called, being wrapped inside the aspect. No, so it's publish comment, and then it's aspect, and then the aspect will also proceed to the real method, and then we'll go back to the aspect. So it will be method, and this log line here 20, no, method name with parameters, and the list of parameters will execute, and then we proceeded to the real method, so that you can see deleting comment, it comes from the real method. And then you see again it comes back to the aspect, method executed and returned, the return of the value, and then it will go into the editing, which is the last one called here edit. So publish comment, then aspect, then delete comment, then aspect again, then edit comment, because all this is wrapped in the aspect. Okay, so imagine this now, because this is the one wrapped inside the aspect. You see publishing comment, and then the first part of the aspect, and then the real method is called, and then you see the last part of the aspect, and then you see the edit comment. No, so publishing comment, first part of the aspect, real delete comment method, last part of the aspect, and editing comment. Okay, so going back to the book now, because we have seen this working. Now we have proved it's working. Let's take a look also now on the figures, because it helps visually, let's say, stick the knowledge a little bit more. So just to remember, this is the aspect. Now this is the definition. So now it will weave to all the methods annotated with the toLog annotation, because that's what the point cut says here. So this will be around all the methods annotated with the annotation. In our case, it's only the delete comment. So when we call that, we will see exactly what you have seen. No, the publish comment, and then the code from around, the real method, code again, edit comment. Okay, and I know, now let's talk. I know in the previous discussion last time, we've also talked about the other join points, but I simply just enumerated them and I didn't go into too much detail. And I've simply discussed about the around, and I've started with around, as I said last time, because this is the most important. This is the mostly used advice, and this is the one that you will see more often and almost in every occasion in real world examples. So now you have 5 actually this kind of annotations. Around is one of them, but you also have the before, the after returning, and the after throwing. Before is the annotation that defines the join point to be called only before a given method. So if you put this join point with any point cut definition, it means that for the given point cut, the advice will be called only before the real method that is weaved to the point cut. If you use after returning, it will only be called to that method weaved to the point cut, but only if the method didn't throw an exception. So this is something like, I want an aspect for the successful execution of a method. If you want something like that, if you want an aspect to execute only after the successful execution of a method, meaning no exception has been thrown, then you can use the after returning join point. If you want an aspect only for exceptions, so it's like the opposite of the after returning, then you can use the after throwing. This would be an aspect that executes only when an exception is thrown out of your method. Imagine, for example, the rollback of a transaction might be done like this. And then after, which means regardless of the method thrown an exception or not, it will always be called that advice after the method execution, either after a successful return or after an exception is thrown. So our company is adopting a microservices first approach nowadays. An unrelated question, but I can quickly answer it. I think in most cases, in my experience, yes. But remember that microservices are not necessarily better than a monolith architecture. They are just different approaches. But let's talk about that more in a different video. Next time I promise I'm going to schedule again an Ask Me Anything session, and we can talk about anything in that one. So just now I'm going to focus better on this topic, which will fortunately finish finally the part 1 fundamentals of the Spring Start here. So I didn't come with too many examples because the idea is very simple. Now you can see it in this listing here. So the only thing you need to know is that instead of using the around annotation as I've done up to this point, I'm using one of the other 4, and depending on what join point I'm using, the aspect will be called relatively to the method execution before, after a successful return, after an exception return, or regardless of it's an exception or not, after the execution, and that's it. Now you might ask me, okay, but if I have the around, which as we talked about and we demonstrated is quite powerful, no? Why would I need the before? Because if I have the around, then I can anyway control anything. And this is true. The around annotation gives you more programmatic power. Now, when you use the around annotation, you have a programmatic possibility of controlling what happens before the real execution, after the real execution, or even instead of the real execution, which is what we have also discussed in the previous video. So that's why, first of all, that's why around is also the most used, and that's why we started with it. Because in many cases, you need that control. You need this programmatic control in which you can decide in a logic that you define what happens before an execution, after an execution, or instead of an execution. This around join point, it can replace all the others. You can use the around endpoint instead of before, because you can control what happens before a method in and around. You can use it instead of after. You can use it instead of after throwing and after returning, because you can anytime use a try catch here and define very granularly to which exceptions and to which situations you apply this. So the around join point gives you a very powerful method, and that's why you, as I've said, will find it in the most implementations. However, theory says that using declarative approaches where programmatic is not needed is better for the cleanliness of the application. So normally, what you have to do is just log something always before an execution, then you don't need an around for that, because your use case only requires something to be done before, and as long as you don't have any other complication, you can just use a simple declarative way, making your, let's say, code simpler and thus more maintainable. That's what the theory says. The practice, even in that cases, I've seen most of the cases people using around, but I'm telling you also, I'm trying to put you all the cards on the table, okay? So can you suggest a way to remember all the AOP terminology aspect? Oh yes, we actually have seen, and I'm gonna go back now, in the last lesson, a diagram here that I find it useful for that. I think it was actually the first diagram in this chapter. Blah, 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 blah. Okay, take a look at this. So just imagine you have this sentence, this phrase here. We want some logic to be executed at a given time. Instead of before, you can put a given time. No, this is just applied to our case here, to our example. We want some logic to be executed before each execution of method which belongs to a given bin. No? So we want some logic. The logic we want to weave, that's called the aspect. That's the extra logic. You want to separate completely. We say it an orthogonal way. No, that's part of the terminology. When you hear an orthogonal approach, it means completely decoupled. You don't find it in the real timeline. No, it's not. It's somehow there, but not in the method. It's orthogonal. So we want some logic, the aspect, to be executed when, before, after returning, after throwing around. This is the advice. No. Before action. Which action? Is the join point? No. Because it's the execution of something in this case, or it can be the execution of some annotated method or something like that. And then the point cut is the whole expression defining the action to which we weave. And then the target object is the bin itself, which is also accessible inside the aspect. If you need it, you can always take it from there. So the aspect is the logic. The advice is when somehow the wrapping, the way the wrapping happens. The join point is the action. The point cut is the expression defining the action. And then the object is called the target. Just to put it like that. If you remember the sentence, I believe that then the rest should be easy to remember. And that's basically with all the advices that you can use now to define all the join points that you can use. And if hopefully that is clear, okay, then we want to complicate also a little bit the things and discuss what happens if you have multiple aspects on the same point cut. Can we have multiple aspects for the same point cut? Meaning, can we weave different pieces of logic? No, because the advice was the separate piece of logic. Can we weave different separate pieces of logic to the same event, aka execution of method X? Can we do that? Technically, yes, and practically at the same time. And that's what we actually call an aspect chain or an aspect chain execution. Why? Because they will not be executed at the same time. No, you need to have an order in which these aspects execute. And it's always recommended you define and you know very well the logic, even when it's not about the capability you implement, but the capability you use. For example, one of the most important, one of the most encountered by me situations. You have a transactional method, but you also apply a pre-authorize or a post-authorize annotation. Now, for those of you who don't know yet, because we'll discuss later transactionability, the transactional annotation helps you wrap a method execution in a transaction, making it possible to roll back. The pre-authorize and post-authorize annotations are annotations from Spring Security that allows you put some security pre or post execution conditions. Imagine that you have a method that writes something in the database. Say it adds a row in a table in a database. This happens, this action of putting in a database happens in the method, of course, because you define it in the logic. But the real action that makes that persistent, which is the commit action, happens outside of the method in an aspect by Spring and manipulated through the transactional annotation. And then the question is, if you have at the same time a security aspect with, which happens if you have Spring Security with a pre-authorize, and the pre-authorize fails, throws an exception, will or not the commit happen? And then, of course, the answer is it depends. It depends because in some cases, depending on the annotations you use, it might happen even if, for example, you have an exception thrown, because it always depends on the order of the aspects. And that's why I'm saying always when relying on aspects, which happens a lot with Spring, when you have a certain capabilities, multiple capabilities linked to the same execution, make sure that you understand in which order are they executed and if the order impacts or not the execution. Just to be aware and make sure that you don't introduce bugs or in some cases even vulnerabilities in your applications. So of course in this section we take a very simple example. So we consider we have some security aspect that applies some restrictions and then some logging aspect that logs the execution. And we can try putting them in different orders so that we see if there are any impacts in the results, in the result. No? So take a look at this. No? So when we have multiple aspects, we actually have multiple proxies delegating one to another. None of these are aware about the other. This is why we call it a chain. So when the main method calls the aspect, as you might remember from the previous discussion, it calls a proxy. The proxy will actually enable the first aspect in the chain. Then that aspect will delegate further with proceed to the next join point. that aspect doesn't know which is the next join point. We'll simply just say delegate further or not. And we'll then delegate further, and then we'll delegate further until it reaches the real method, which is the join point. And then we'll go back. Or it might not delegate further, case in which everything stops. No? At that point, we'll just return without going further in the chain. So if we have, let's say we have these two situations, no? If we have a different order, if the security aspect is the first one, and then the rule will apply. This is wrong here. This x here should not be the case. I think it should be the x should be here on the right side. So this is a small mistake in the book, okay? Because in both cases the security aspect will reject, no? So point is, if the security aspect is before the logging aspect, then when the security aspect doesn't allow the call to proceed, the logging will not happen either. But if we define the order of the aspects in the other way around, the log aspect will decide to log the execution, even if in reality the execution doesn't happen. So the mistake here is that this red X should be here on the last step, because it's still the security aspect not delegating further, okay? But I think you can see what I mean. But the result is different, because in this case, in the first chain, no one logs the execution of the method, which is good because the method didn't execute. It was interrupted by some security conditions. But in the second chain, in the definition we have used for the second chain, might be confusing, because someone looking in the logs might see that the publish command has executed, but will not see the result and will not understand why. And of course, normally the security aspect would also have some observability in place, but point is, it's still misleading if you'd see that, I don't know, the method executed, but in reality it didn't execute. And of course, this is just a simple demonstration, but the impact of not using properly the order of the aspects might lead into even more complicated situations. So usually you need to be very aware on how you define your aspects. And now I'm going to the other example that I didn't want to show you at the very beginning. When you have multiple aspects, then you can use the order annotation to instruct Spring which is the order in which you want the aspects to execute. So if you want the security aspect to be first and then the security aspect to be the second, you just have to put them in the given order. Okay? And then what you can do is exactly what I did here. You try to play with them. So just try to enforce one order and then the other, and you will get in one of the cases you will get what happens here in figure 6.15 now, where we have first the logging and then the security, and then the other way around you'll have the security and then the logging. So just to play with it, to see that you can manipulate the order in which this executes. And that, my friends, was part 1 of the book, where we have discussed everything that I consider the foundation of Spring. From my point of view, as I have been saying that for some time, there should be no developer, no Spring developer, not knowing all these first 6 chapters that we have discussed here. That's why I'm always bringing into attention to developers starting working directly with Spring Boot, which is a project over Spring, without knowing Spring in the first place. Remember that you don't only want to learn how to drive a car, you want to also be able to fix it when it's broken. You are not a driver, you are a mechanic of a car. Of course, you need to know how to drive the car as well, but that's not enough. You as a Spring developer need to know also how Spring works behind the scenes and not only learn how to use some annotations. Otherwise, you might improperly use them, or simply when you run into trouble, you might find it very difficult to get out of the trouble or understand what happens if you don't know the behind the scenes. So if you want to really be professionals, I know it's boring, I know, and many people said, hey, your part 1 of the book Spring Start Here is boring. And it is boring, I don't say it isn't, but it's necessary. If you want to be real Spring developers, the most important piece of advice I can give you is learn at least the basics of the framework, at least this. So again, what I put in this book, it's not everything. This book is not a documentation, and I didn't even want it to be. It didn't make sense. This what you have here is the minimum in the exact order one should learn to be a real, or to become a real Spring professional in the end. So for next time, homework for you, review everything and try to learn it as good as possible. Review these first 6 chapters, understand them well. Leave me all your questions in the comments as you always do, or join the Discord channel and let's chat together on Discord as well. And next time we will start with a little bit more entertaining part, which is implementation. It's still fundamentals, because Spring Start Here, as the name suggests, is where you start learning Spring. So it doesn't make you experts, it gives you all the foundation for you to become experts in the end. But it's still, part 2 is still a little bit funnier and more entertaining, because it looks like we are building some more real stuff. But even in the next chapters, when I'm going through what I'm discussing, I will still always refer back to things that we have discussed in chapters 1 through 6. And we have also a question which I want to answer. If we don't put any order on the aspects, so that's related to last section of chapter 6.3 that we have discussed today. Does it mean that the order of aspect execution will be random, or does it depend on the order that you have them on a method? So it's not random, it's not guaranteed. I want to make you aware of a very important difference. Because in many cases I'm hearing the usage of the random word wrongly used. Random would mean that when you call, it might always be a different order, no, which is not the case. So you will if you don't use the order, you will have a defined order, which I don't even remember last time what was depending on. I think it simply depends on the bytecode itself, but it's very important actually to remember it's not guaranteed. It means that you shouldn't rely on that. It can always change. No one guarantees you, if you didn't put order, that when you upgrade the Spring version, for example, that order that now happens will also happen. It will be the same in the next Spring version. So when you don't use the order annotation, you don't have a random execution, but you have a not guaranteed execution. It might be one order or another. It might be one order now and then change later when you upgrade the version for no reasons, which might impact the execution. And that's why we need to have an order specified always. Because in most cases, I know there are situations where the order of the aspect is not relevant, but in many cases it is. If it's not relevant, then it's fine. You can take it as not guaranteed. You don't care what is the order in which it's executed. But if the order matters, like for example, let's say in this case with the logging and security, the order matters, then it's best you ensure the order. Okay. Any real-world advices on troubleshooting issues with Spring built-in libraries, aspects, annotations like yeah, I mean, yes, it's one of the things that I encounter maybe the most when I'm troubleshooting with Spring, because yes, as you say, AOP is like the magic, the magic fabric behind Spring. So whenever you will use Spring, you will get into this. But I don't have actually any more troubleshooting Javas behind me because I just sold the last one last week. But the point is, in the troubleshooting Java, which is a book I will also create a series for here, and on which I'm working now on the second edition, by the way. I'm discussing sampling and profiling, which is what I'm using the most when trying to investigate situations with orthogonal execution such as AOP, because as you have spotted, sometimes it's difficult to simply debug it. So I cannot just simply discuss now in a couple of minutes on how to do that here, but I promise I will integrate it in different other videos. Okay, and with that being said, friends, thank you very much again. We finished part 1. Woo, good job. So we will continue with second part, the implementation, as still fundamentals, but now we are a lot more a lot closer to the objective, to our target of being real professionals with the Spring framework. Thank you very much, everyone. I'm waving goodbye and see you next time to start with part 2. Bye, everyone.